This training video outlines the steps to create your first sequential function chart in Automation Studio. In the process of recreating this circuit and chart, the user will learn how to create a circuit with generic components from the library, how to do circuit addition, how to assess component properties and help, how to add a SFC logic, and how to run the simulation and analyze the circuit. In this video, we will create a circuit where two pneumatic cylinders will be controlled by an SFC. All components needed for this first circuit are located in the main pneumatic library. Simply click on it to display components. In order to create the circuit, move the components from the library onto the schematic. To do so, select the desired component from the library, in this case a pneumatic pressure source, and drag and drop it onto the schematic while holding down the left mouse click. Similarly, drag and drop a double acting cylinder, a 5x2-way valve with a manual command and a solenoid, and two exhausts. To zoom in the schematic, go to the View tab of the ribbon bar and click on Zoom in function under the Zoom tools. Other zoom functions like Zoom page, Previous zoom, Zoom all components can also be found at this location. Alternatively, to zoom in and out, press and hold down the Control key, then scroll up to zoom in or scroll down to zoom out of the page. Software will zoom where you are pointing your cursor. To pan the document, click on the panning function of Zoom tools. When you click on the panning function, the cursor transforms into a hand and then you can pan the document by holding the left mouse click and moving the cursor. Alternatively, you can press and hold down the space bar and move the cursor to pan the document. To disable this function, just right click on the document. Now connect all these components to create the pneumatic circuit. To connect components, move your cursor over a red connection port and click when the target sign appears, release the button, draw your line with the cursor and click on a second connection port to establish connection between those two components. Both connection ports automatically become black when linked. In order to connect the exhaust with the directional valve, select an exhaust and drag and drop its connection port over the connection port of the 5x2-way valve. Similarly, connect the other exhaust to the valve. In order to connect the working ports of the 5x2-way valve with the cylinder, you need to change path during connection. To do so, when drawing a line while moving your cursor, click when you need to create a 90-degree turn and connect. Similarly, connect the other working port of the directional valve with the cylinder. Now that all the components are connected, you can start the simulation. Go to the Simulation tab of the ribbon bar and click on Normal Simulation icon under the Control tools to start the simulation. While in simulation, when hovering over a component, if the cursor turns into a hand icon, you can click to interact with that component. The directional valve on this circuit has two commands, a lever and a solenoid. Since the control circuit is not yet created, activate the manual command by clicking on the lever to get extension and retraction of the cylinder. Stop the simulation by clicking on Stop Simulation icon under the Control tools. Now let's complete the pneumatic circuit. To do so, duplicate your first circuit. For that, click and hold the left button of the mouse and move the cursor to select all the components. Then release the mouse button, press Ctrl key and drag and drop the selected components to the right of your first circuit. Now we need to add few more components on the schematic to complete the circuit. Drag and drop a pressure regulator, now navigate through the pneumatic library and open the fluid conditioning category. Select the filters folder and drag and drop a filter. For the final pneumatic circuit, only one pressure source is required. Click on a pressure source and press the delete key of the keyboard in order to delete it. Now disconnect the other pressure source from the circuit. To do so, press and hold down the shift key, click on the component and drag it elsewhere on the schematic. If you need to change the visual representation of a component, functions to rotate, flip, align, distribute and order components can be accessed from the Edit tab of the ribbon bar under the Layout tools. Just click on the component and select desired functions, or right-click on component and select desired manipulation functions, or simply use assigned hotkeys. To visually adjust the component layout before doing connections, click on the pressure source, then click on position function in the layout tools and select rotate right 90 degree and connect these components. While tracing a line coming across another line, there is no target sign that usually allows you to make a connection. Therefore, you need to double-click on the line to make a junction. When a 3-line junction is created, a filled black connector is automatically created at the junction. Now, 2 new variables need to be created in the project in order to create an association between the directional valve solenoid and the SFC. For that, go to the Tools tab and click on Variable Manager of the Management Group. Then click on Add Variable command from the top left corner of the Variable Manager. Select the type bool and name it A for both name and alias. Click on the green check button to validate and repeat the steps for a second variable named B. Close the Variable Manager window. Now associate question mark variable of the electrical solenoids of the directional valve with the newly created variables. For that, you need to access the Component Properties window of the component. To open the Component Properties window of the directional valve, right-click on it and select Component Properties. You can also open the Component Properties window by double-clicking over the component. Click on the Variable Assignment from the left side menu. Click on the left solenoid icon of the directional valve. Select question mark variable from the Component Variable section. Use the filter from the Compatible Simulation Variable sections to sort the variable and only show the one matching your criteria. Select a variable and click on this command to create an association. The newly created association appears in the Associations section. Close the window and repeat the same steps to associate question mark variable of the electrical solenoid of the second directional valve with the variable B. All components in Automation Studio also have a help file describing their functionality. Right-click on a component and select Context Help. In this window, you can get information about the operation of the component and its features. This window also provides a description of each property of the component available in the Data tab of its Component Properties window, such as properties related to its modeling, characteristics, external data, operating condition, and so on. Close the window. You can also access the help file by clicking on the component and pressing the F1 key of the keyboard. Now open the sensors category of the pneumatic library. Select proximity sensors folder and drag and drop 4 proximity sensors onto the schematic and give them alias A0, A1, B0 and B1. The alias for the component is displayed on the schematic and is used to identify the component by linking it with other components. The proximity sensors are used to send a signal when the cylinder reaches a specific position. This signal is used in the SFC to obtain an automated system. Position the sensor A0 above the piston of the first cylinder with an extension of 0% and match the position of the diamonds. Similarly, position the sensor B0 above the piston of the second cylinder. Double-click on the cylinder to assess its component properties and assess the data branch. Modify the extension to 100%. Now position the sensor A1 above the piston of the first cylinder and set the extension back to 0%. Repeat the same steps for sensor B1. Now insert electrical switches to control the automated system. From an electrical control library, IC standard in this example, assess the switches category and insert a 2-position switch and a normally open push button. When inserting an electrical control component on the schematic, the software asks for an alias for the component which is displayed on the schematic and is used to identify the component by linking it with other components. Let's give it an alias on/off and apply. Now insert an SFC document in the project. For that, go to the Automation Studio menu, select New Document and click on Sequential Function Chart. A Sequential Function Chart Templates window pops out. From this window, choose the template default and click on OK and click on green check button if an export warning document pops out. Observe that a new document SFC1 has been added in the project. Go to the Home tab and from the SFC tools, select Alternate Step Transition command and insert 3 steps and 3 transitions in this manner. Right-click anywhere on the document to release the step transition cursor and zoom all components. Now in the View tab, click on the vertical tile of the window section in order to view both documents simultaneously and adjust the view of the schematics. Click on the Auto Hide symbol of the Library Explorer to hide it. Set the first step as an initial step by double-clicking on step 1 to assess its properties. Then select Initial in the Type drop-down menu. Apply the changes and close the window. The starting condition for this circuit will be the on-off switch activation. By setting the on-off variable as a transition condition, the chart will move to next step only when the variable will be activated. In this case, to go to step 2, you must click on the push button. To set this condition, double-click on transition 1 to access its component properties. In the variable section, write on-off in the field next to alias to filter the variable list. Double-click on on-off variable from the list. It should now appear in the conditions area. Apply changes by clicking on green check button and close the window. The first action of the chart will be to activate solenoid A of the directional valve in order to extend the first cylinder. To set this action, double-click on step 2. In the variable section, write A in the field next to alias. Double-click on the A variable from the list. It should now appear in the actions area. Scroll down to the syntax and operators section and click on :=1 command. This means A is set to true at each simulation cycle and keeps this state. Check in the action section to make sure that the assignation is good and apply changes by clicking on the green check button. Similarly, set the condition in transition 2 that the first cylinder is fully extended in order to go to step 3. Set the next action in step 3, which is to activate solenoid B in order to extend the second cylinder. Now set the condition in transition 3 that the second cylinder is fully extended in order to go back to step 1. In step 1, set the action that both solenoids A and B are deactivated. Now connect steps and transition to complete the chart. To connect transition 3 to step 1, simply draw connecting the end of transition 3 with the input of step 1. And the jump will automatically created. Now that all the components are connected and all the links are created, you can start the simulation to see your circuit come to life and the interaction between the different technologies. While in simulation, click on on-off to start the cylinder's extension cycle. At this point, two position switch is not connected to anything. During the simulation, you can follow on the SFC the evolution of the cycle. When a variable is activated, it is highlighted on the chart. Stop the simulation. For cylinder A, and B to retract at the same time, two steps can be used to be simulated simultaneously. An AND logic is defined by the connection of two steps to one transition. Thus, both steps are executed at the same time. To add an AND logic to your chart, insert two steps below transition 3. Delete the connection between transition 3 and step 1 by pressing the delete key of the keyboard. Click on the output port of transition 3 and connect it to the input port of step 4. Again, click on the output port of transition 3 but connect it to the input port of step 5. Insert a new transition and connect it to the output ports of step 4 and 5. A double line will be automatically created between transition 3 and steps 4 and 5, identifying an AND logic. An OR logic will be used for the activation of the automatic mode by using the state variable of two position switch. An OR logic is defined by the connection of two transitions after one step. To add an OR logic to your chart, insert one step and two transitions. Connect the output port of step 6 to the input of transition 5. Again, click on the output port of step 6 but connect it to the input port of transition 6. A line will be automatically created between step 6 and transition 5 and 6, identifying an OR logic. Now complete the chart by first defining actions and conditions for newly inserted steps and transitions and then connecting them. For cylinder A and B to retract at the same time, the actions for step 4 should be deactivation of solenoid A and that for step 5 should be deactivation of solenoid B. Define these actions in respective steps. Now set the condition in transition 4 that both the cylinders are fully retracted in order to go to step 6. We have given condition that both B0 and A0 are true. Now connect transition 4 to step 6. Now set the condition in transition 5 that the two position switch is activated by assigning the value 1 to its state variable. Since there are so many state variables in the project, in order to identify the state variable of the two position switch, rename it. Double click on the two position switch and rename the state variable to state underscore auto. Now go back to transition 5 and set the desired condition. Similarly, in transition 6, set the condition that the 2-position switch is deactivated by assigning 0 value to its state variable. Now connect the output of transition 5 to the input of step 2. And the output of transition 6 to the input of step 1. From these connections, if the 2-position switch is activated, the chart will return to step 2 after step 6 and the cylinder cycle starts again. If the 2-position switch is deactivated, then the chart returns to step 1 after step 6. Start the simulation and observe the behavior of the circuit for different conditions set in SFC. You can observe that if 2-position switch is active, the cylinder cycle starts again. But if the 2-position switch is deactivated, then the cylinder cycle stops and the chart ends at step 1. Similarly, you can create different SFC logics to control a circuit.